Bismillah and Assalamualaikum. In today's video, we will learn about discrete probability distribution. Alright, now I think I mentioned already the definition in the previous video. So the definition over here says that a discrete random variable is a random variable that is countable. Again, countable, something with a whole number. You can count 0, 1, 2, 3 and so on. Okay. Now there are two properties of a discrete probability random variable, which is probability of x should be between 0 to 1, and your total px should be equivalent to 1. Now, discrete probability distribution can be represented in three ways, which is the first one in probability distribution table, and then probability distribution function, and also probability distribution graph. Okay, now let's look at examples on how to actually construct the table, function and graph, probability distribution function, table and graph. Now let's say you consider an experiment where tossing two fair coins simultaneously, and you let x be the number of heads obtained, and then they ask to construct the probability distribution table. So first and foremost, when you get this kind of question, identify your random variable. Okay. Now over here, they already given that your random variable should be the number of heads obtained. So write it back. So x is your random variable with the number of heads obtained when tossing two fair coins simultaneously. So, and then the next step is that you identify the possible value of x. Okay. Now, what are the possible values of x that you might get? So, the question is that how you can get it. Alright. You can get it from your sample space, which is S. So, if you toss two fair coins, what are your sample space? So you might get a head and a head when you toss two fair coins. Now, do you know how to get it? You can actually draw from tree diagram. Let's say the first coin, let's say this is the first coin. So your outcomes might have head and tail. Alright. Now for second coin, still you get whether head or tail. Alright. And then if you get a tail, you might get also head and tail. So these two fair coin, so the outcome, you can get whether the first is head, the first is head, the second is head. Alright, and then you can get a head and tail, or tail and head, or tail and tail. So there are total 4 outcomes over here. So you can write it back, which is head tail, and then tail head, and tail tail. Okay. Now again, ask yourself, what is your random variable? So x is your random variable, number of head obtained. So write it down. So how many head obtained? Now from the outcomes, let's look at the first outcome. Let's say head and head. How many heads are there? You might get x equivalent to 2 heads. Alright. For head and tail, your x can be equivalent to 1. For tail and head, your x number of head obtained might be equivalent to 1. And for tail and tail, is there any head? There is no head, so your x would be equivalent to 0 head obtained. So these are the possible value of x. So you might get 0, 1 or 2. To construct the probability distribution, just write two things, where your x and your probability of x. So the possible value of x just now you got whether you're going to get 0, 1 or 2. Now, how to get the probability? Now, just put if probability of x equivalent to 1, I should take started from 0 first. Now, let's look at when x equivalent to 0. Now, what is the outcome when x equivalent to 0? You get the outcome of probability of tail and tail. So this is actually probability when you get a tail and a tail. So basically how you get the probability is that if the first toes you get a probability to get a tail is half, and the second toes you get a probability of tail is also half because it is independently event. So to get the outcome probability of tail and tail, basically half multiplied by half, where you get 1 over by 4. So your answer should be probability of getting x equivalent to 1 is 1 over by 4. Or in other ways, if you look at your sample space, how many are they? The total sample space? There are 4. What is the probability of getting tail? Is actually equivalent to 1 over by 4. That's how you do it. Okay. Now, for px equivalent to 1, how you get it? Now, you can always do it from the tree diagram. Now let's look at the sample space. So what you do is that for getting a hit once, you might get whether from hit tail or you might get from tail head, probability of tail head. So how many are they? There are 2 possible outcomes. So 2 out of how many total sample? There are 4. So if you simplify, you're going to get half. So this one would be half, where you can put inside the table. Okay. Now, probability of hit have 2. What are the outcome, possible outcome? There is only 1 possible outcome out of a total of 4. So, probability of x equivalent to 2 basically is 1 out of 4, which is 1 over 4. So, now you complete already your probability distribution table. Okay. Now, how you want to know whether your probability distribution table is correct or not? So, now go back to your properties. Says that probability of x should be between 0 and 1. And the total px is equivalent to 1. Now check the 2 properties. Are these probability between 0 and 1? So this one check correct. Now probability when x equivalent to 1 half is between 0 and 1. 1 over 4 also between 0 and 1. Now check your total px. So total px, you can always check it. Total px, now I'm just going to write it here. Total px basically is equivalent to px equivalent to 0 plus px equivalent to 1 plus by px equivalent to 2. Alright, I'm going to erase this a bit. Okay, so when px equivalent to 0, your probability is 1 over by 4. Plus by px equivalent to 1, 1 over by 2, plus by px equivalent to 2, 1 over by 4. If you total up, you're going to get here is 4 over by 4, which is equivalent to 1. So it is correct, your probability distribution. Okay? Now, let's see if you want to do probability distribution function. Okay, now pause a bit if you do not understand. Try to go back and understand what we have done, how to get the distribution table, then come to the probability distribution function. Because to draw or to construct probability distribution function, you need to have probability distribution table first. Okay. Now, probability distribution function. Now, your function over here is px. Now, this is like the piecewise defined function. So, what you write is that your function px is equivalent to, Now, piecewise defining function will give you this curly bracket, a big curly bracket. Now, what is the smaller value between the probability? So you have 1/4 and 1/2. The smaller one will be 1/4. So put it 1/4. And another one will be 1/2. Now, when does it happen that the probability is 1/4? So it happens that when x equivalent to 0, is it only at 0? Also happen at 2. So put it 2. When does it happen when probability is 1/2? When x is equivalent to 1. So, what happen if I ask you what is the probability of x equivalent to 3 or 4 or 5 and so on and so on? Now, from here you only get your x 0, 1, 2, right? So, what happen is that when the number is elsewhere besides 0, 1 and 2, your probability will give you 0. You can say that x elsewhere. Okay? So that's how you construct probability distribution function. Now, to construct probability distribution graph is very simple. Just take from your probability and your x. So you got x 0, 1 and 2. Okay. And then what is your probability? You have 1/4. So write it 1/4. Probability of another one will be 1/2. Oh, by the way, the x's would be, this is x, this is px. So when px equivalent to 0, your probability will be 1/4. Now just draw a line graph, okay? And then when x equivalent to 1, your probability of x would be equivalent to half. So draw the line graph into. And then when you got px equivalent to 2, your probability is 1/4. So draw another one line graph. Okay. So that's how you do it. Okay. Again, try to do some exercise for you to understand. Alright? Okay.